Hello viewers, this is Wagada Ronald taking you through today's tutorial on further integration. And today's lesson shall talk about integration by using tangent and secant substitution. So we shall start with the method of using tangent substitution. In this method, the integral has been the form whereby the denominator is a constant plus a variable x squared. And in this case, we can use this method by first letting the whole of this part, which has a variable, to be equal to this constant a squared multiplied by tan squared u. So we shall say let b squared x squared be equal to a squared tan squared u. And while you relate that, we have to remember that 1 plus tan squared u is equal to sec squared u. So we shall start with problem 1. Problem 1 says that find the integral of 1 over 4 plus 9 squared x squared with respect to x, and hence evaluate the same integral with limits from 0 to pi over 6. So the first thing to do is to let this part with a variable to be equal to this constant 4 multiplied by tan squared u. So we shall come and say let 9 squared x squared be equal to 4 tan squared u. Then from there we shall put square root on both sides to come up with 3x for this, and square root of this will give you 2 tan u. Now that you have got the square root, you can easily differentiate, but before you differentiate, you have to first make u the subject. It will help up somewhere. So when I make u the subject, I'll come up with u equal to arctan 3x over 2. And when I differentiate, I'll come up with dx du being equal to 2 over 3 sec squared u. After that, I'll make dx the subject. When I make dx the subject, I'll come up with dx being equal to 2 sec squared u du over 3. And now that I have now that I have dx, I'll come and substitute for dx in this integral. And also substitute for x. Now the whole of this 9x, remember we said let 9x squared be equal to 4 tan squared u. So wherever there is 9x squared, we are going to put there 4 tan squared u. And also know that dx is equal to this, so we shall replace this x with that. Now that I have replaced, we shall now simplify. I know that there's 4 which is common, and I'll come and say 4 which was here multiplied by 3 will give me 12 as the denominator, but remember I have 2 up, so this will reduce this 12 to give you 6, and this is the 6 you're seeing here. That means that up the numerator we only have now sec squared u, which is this, and this u is what is here. So now we have integral of sec squared u. The denominator is 6 in brackets 1 plus tan squared u. But remember 1 plus tan squared u is equal to sec squared u. So we shall come and substitute for 1 plus tan squared u to give me sec squared u over 6 sec squared u. I think you realize that these 2 can cancel and you remain with 1 over 6. So when I integrate 1 over 6, remember 1 over 6 is a constant. When I integrate, I'll come up with 1 over 6u, but don't forget the constant of integration. And now that I've got the integral, remember this u, we are the ones who introduced it there, so we have to again eliminate it by remembering that u is equal to arctan 3x over 2. So my integral will now be 1 over 6 arctan 3x over 2 plus c. But now we shall go to the hence part. The hence part, they told us to integrate the same integral but with the limits of 1 to pi over 6. So this is my integral, and now I've put there the limits. The next is to substitute for these limits. So wherever there is x, I'll begin with the upper limit. Where there is x, I'll put there pi over 6. When I put pi over 6 here, I'm going to come up with 3 over 2 times pi over 6. And to reduce to this 3 will reduce this one to give me 2. So in the end, I'll come up with pi over 4. This 2 and this 2 will give me 4, so I'll end up with pi over 4, which is this. Minus, I'll have to substitute for my lower limit here. So when I put 0 here, any number multiplied by 0 is 0. So I'll end up with arctan 0. Then when I use the calculator, remember the calculator now has to be in radians. So when I press the calculator, arctan pi over 4 will be equal to 1. And arctan 0 will be equal to 0. And when I simplify this, I'll come up with my answer as 1 over 6. So now we shall go to problem 2. Problem 2 says that find the integral of 1 over x squared minus 4x plus 313 with respect to x. So I think I realize that now the denominator is not yet in the form which can enable us to use tan substitution. So what do? We have to first complete squares so that the denominator is now in the form this. So let's now complete squares. Completing squares means, look at this coefficient of x, it is 4. Divided by 2, you'll come up with 4 over 2 to give you 2. Therefore, come and say in brackets that x minus 2 squared minus, now this value comes from this coefficient squared. So when I square 2, I'll come up with 4. This is where that 4 is coming from. Now for these two terms are equal to this from here up to here. Then I'll add on my constant 13, which is this. And when I simplify, negative 4 plus 13 will give me positive 9. Now that I've managed to express it in the form that can easily help us to use tangent substitution, we shall go ahead to use the method. So in this case, this integral is equal to this integral. So we shall now let the whole of this to be equal to this constant, which is 9, times tan squared u, as we said at the introductory part. So next I'll put the square root on both sides. When I put square root on both sides, I'll come up with x minus 2 being equal to 3 tan u. And before I differentiate, I'll have to first make u the subject to give me u being equal to arctan x minus 2 over 3. So don't forget this, because at the end we have to substitute for u. So now I'll differentiate to get dx du being equal to 3 sec squared u. Now when I make dx the subject, I'll come up with dx being equal to 3 sec squared u du. And now that I've got dx, I'll now substitute for my dx and my x. So remember we said the whole of this is equal to 9 tan squared u. So I'll come and substitute for this to put there 9 tan squared u. Then dx is equal to 3 sec squared du. So I'll come and substitute for dx. Now next is to simplify. When I simplify, you realize that this one 9 is common in both, so I'll pull it out to become 9 in brackets 1 plus tan squared u. But this 9 and this 3 can reduce each other so that we remain with 3 down here, which is this 3. And this sec squared will come here to become this. So we integrated with respect to u. And remember, 1 plus tan squared u is equal to sec squared u. So I'll come and substitute for 1 plus tan squared u to give me that. Then I realize that these 2 can cancel to remain with 1 over 3. Now 1 over 3 is a constant. Therefore, when I integrate, I'll come up with 1 over 3 u plus c. But remember, we are the ones who introduced u, so we have to eliminate it, and we got our u as arctan x minus 2 over 3. So I'll come and substitute that to get an integral 1 over 3 arctan x minus 2 over 3 plus c. So that is the integral they wanted. So now we shall go to problem 3. Problem 3 says integrate cos over 1 plus sine squared x with respect to x. So the first thing to do is to let the whole of this, which is sine squared u, to be equal to this coefficient, which is 1 times tan squared u. So we shall get x sine squared x being equal to tan squared u. So next we shall be to put the square root on both sides. When we put the square root on both sides, we shall come up with sine x being equal to tan u. So before I differentiate, I'll first make u the subject, which will give me u being equal to arctan sine x. Now when I differentiate both sides with respect to x, differentiate sine, I'll come up with cos x. And when I differentiate tan u with respect to x, I'll come up with sec squared u du dx. And when I make dx the subject, I'll come up with dx being equal to sec squared u over cos x du. Now that I've got dx, I'll come and substitute for dx and in this expression. So my dx will be equal to sec squared u over cos x du, which is that. And remember, we say that sine squared u is equal to tan squared u. So where there is sine squared u, I'll put there tan squared u. Now this one, I'll first leave it without replacing it in terms of u, because my expression of dx also has cos x. So in the end they can cancel. And when they cancel, remember this and this will cancel. But also remember that 1 plus tan squared u is equal to sec squared u. So this one and this one will also cancel in the end. So let's first cancel this and we come up with this expression. Now tan 1 plus tan squared u is equal to sec squared u. So we shall come up with this part of sec squared u, and you realize that this and this can cancel to remain with 1. So in the end I'll have to integrate 1 with respect to u. When I integrate 1 with respect to u, I'll come up with u plus c, where c is the constant of integration. But remember, we are the ones who introduced u, so we have to eliminate it at the end. So remember, u is equal to arctan sine squared x. So in the end my integral will be equal to arctan in sine squared x plus c. Now shall go to integration using secant substitution, and this method is used for integrals in the form where the denominator has a square root, but it starts with a variable x squared minus a constant. Remember, and in the previous topic of using sign substitution, the expression was also having a square root at the denominator, but it was starting with a constant minus the variable x squared. So in that case we use sign substitution, but in the case where it starts with a variable x squared minus a constant, in that case we use secant substitution. And this is done by letting the whole of this variable being equal to this constant b squared multiplied by sec squared u. In other words, we shall say a squared x squared is equal to b squared sec squared u. And also remember that 1 plus tan squared u is equal to sec squared u. When I make sec squared tan squared the subject, I'll come up with sec squared u minus 1 being equal to tan squared u. So this is the expression we shall be using under secant substitution. We use this one under tangent substitution, but now in this case of secant substitution we shall use this. So shall start with problem 1. Problem 1 says that integrate negative 4 to 0 of the square root of 6x plus 6 over x plus 2 with respect to x. I think I realized this thing that this one is not yet in the expression, which can enable us to use secant substitution. So you have to first simplify it so that it's in the form this one, so that we can easily use secant substitution. How do we do it? First of all, this one is the same as square root of 6x plus 6 plus, sorry, divided by x plus 2. But remember, we want the denominator to have the square root, so introduce an innocent expression by multiplying both up and down by this numerator. So we shall multiply this by this and also this by that, the same expression. And when you do that, this and this will give you x plus 6. I think we're realizing that now the square root is no longer on the numerator, and the denominator will have the square root. When I expand this, I'll come up with this. So when I expand this, I'll come up with this expression, which is x squared plus 8x plus 12. But this expression is not yet in this form, so to make it in this form, we have to complete squares. So how do you complete squares? First, deal with these two parts with terms with x. Look at this coefficient of x, it is 8. When you divide 8 by 2, you'll come up with 4. So you come and say x plus 4, everything squared, minus, now this one which is here is 4. When I square it, I'll get 16, and that is where this 16 is coming from. So you have dealt with this part and this part. After that, we have to add on this constant. So I'll come and say plus 12. Now after that, I'll simplify. Negative 16 plus 12 will give me negative 4, which is this. So in the end, I think I'm realizing that now I've got an expression in the form this. Now that I've got that, it implies that this integral is the same as this integral. So we have managed to get an expression in form of a variable minus a constant. Therefore, we can use secant substitution. For secant, it means the whole of this, which is x plus 4 squared, will be equal to this constant 4 multiplied by sec squared u. So shall come and say x plus 4 squared will be equal to 4 sec squared u. Next is to put the square root on both sides to come up with x plus 4 being equal to 2 sec u. And when I differentiate, I'll come up with dx being equal to 2 tan u sec u du. Now that I've got the dx, I also have to change the limits. So remember, these are limits for x, but now I want limits for u. We say that x plus 4 is equal to 2 sec u. That means that x plus 4 over 2 will be equal to sec u. But also remember that sec u is the reciprocal of cos u. So in other words, cos u will now be equal to the reciprocal, this reciprocal, which is 2 over x plus 4. Now I'll go to the limits. I'll start with the lower limit, is negative 2. So come and substitute negative 2 here. I'll get negative 2 plus 4 to give me positive 2. Therefore, 2 over 2 will give me 1. Therefore, cos u is equal to 1. And therefore, arc cos u will give me 0. Go to the upper limit. Upper limit is 0. So come and substitute here 0. So 0 plus 4 is 4. And 2 over 4 will give me 0.5. Therefore, cos u is equal to 0.5. And arc cos of 0.5 will be pi over 3. Remember, we use radians. So now we shall substitute dx. We got our dx as 2 tan u sec u du. And remember this, the whole of x plus 4 squared is equal to 4 sec squared u. And my x was the same as 2 sec u minus 4, and this 6 is that. Now next is to simplify. We shall start with this square root. So 4 is common, so I'll first pull it out to get sec squared minus u, but sec squared u minus 1, but sec squared u minus 1 is equal to tan squared u. So in the end I'll get the square root of 4 tan squared u. Now the square root of 4 tan squared u is 2 tan u, and that is where this 2 tan u is coming from. Then here negative 4 plus 6 gives me positive 2, that is where this plus 2 is coming from. So basically that's the part from this to this. Now from here to this 2 will cancel first, and this tan u will cancel, so you remain with sec u du, which is this. And for this part 2 is common, so we shall pull out 2 to come up with this 2 which you are seeing here, and when you pull out 2 we remain with sec u plus 1, which is here sec u plus 1. So in the end we get the integral of 2 in brackets sec u plus 1 multiplied by sec u du. So now we shall expand, open brackets, to come up with sec squared u plus sec u. And when I integrate sec squared u, I'll come up with tan u, and when I integrate sec u, I'll come up with ln of magnitude tan u plus sec u. The limits are from 0 to pi over 3. And from that I'll substitute now the upper limit in this expression. So substitute pi over 3 wherever there is u here to come up with this bracket, and then substitute 0 wherever there is u here to come up with this bracket. Now tan pi over 3 is the same as, is equal to root 3, so I'll put root 3 here and also put root 3 here. Now sec pi over 3 is equal to 2, so I'll put 2 here. For tan 0 is 0, so I'll put 0 here, and tan 0 is 0, so I'll put 0 here. Sec 0 is 1, so I'll put 1 there. And next I'll simplify. When I simplify, open this bracket, I'll get 2 root 3, which is this, and 2 ln of root 3 plus 2, which is that. Now for this part, 0 is already 0. Now ln 1 is equal to 0, so the whole of this becomes 0. Therefore, the integral which was required is the value of the integral which is required is 2 root 3 plus 2 ln of root 3 plus 2. So it's now your turn to go through the following integrals. So that is problem 1. Compare answer with that. That is problem 2. Compare answer with that. And that is problem 3. Compare answer with that. So that has been our lesson for today. Thank you for watching, and please subscribe to my channel, Rowa e-learning platform. Thank you.